This video takes a look at 3 examples using the AC method of factoring. And so that AC method of factoring is a particular method that essentially changes the look of the problem to something simpler. The method itself I'm not a big fan of simply because I don't understand why it works very well. And so that it works is more important at this point in most students' minds than why does it work. But as an instructor, I really don't feel comfortable teaching a method that I don't understand. However, here are 3 examples that use this particular method. And now as the warning, you've got to factor out any greatest common factor from the quadratic before you begin to factor using this AC method. If you don't, it'll fail. And I'm going to show you that in the third example. So here we have our first example here. By the way, if you're not familiar with the AC method of factoring, I do have a video that goes through each and every step that I do, and there are 5. Each and every step that I do and explains the steps in words, so you can have that as reference as well. So just search on YouTube for AC method of factoring. Okay, here we go. In the first step of our AC method of factoring, we grab up the lead coefficient, we remove it, and multiply it by the constant coefficient. And that answer goes back into the constant coefficient. So 2 times 5 is 10. That's step 1. Step 2, we factor our answer from step 1 just like we would if it were any other quadratic. And so we're going to have to find 2. And if you're not one of my students and haven't seen the signs method before, I just call it the signs method. I don't know if it really has a method. But I use these signs to tell my students exactly how to factor these. It makes it very, very simple. And so according to this, first of all, I've got x squared up front. The only way to get it is to have x and x. The second sign tells me that I multiply 2 numbers to get a negative, and that means that one of them is positive, one of them is negative. Which one? Don't care. However, the middle sign tells me which one must be negative. All right, so now I need 2 factors of 10 that subtract. That second sign tells you that they must subtract to make 3. 2 and 5 do that. 5 minus 2 is 3. However, the larger of those 2 factors, 5 and 2, get that sign in front of 3. So 5 gets the negative and 2 gets the positive. All right, that's step 2. So step 1 is remove the lead coefficient, multiply it by the constant coefficient, and make that your new constant coefficient. Step 2, factor the new quadratic with a lead coefficient of 1, just as you would for any other version of that. Step 3, you are going to replace the original lead coefficient back into each lead coefficient spot of the 2 factors you've just created from step 2. And so this is going to go to 2x plus 2. This is going to go to 2x minus 5. All right, step 4, and this is another one of those funky things. Step 3 and 4 are just, they wig me out for some reason. You're going to factor out the greatest common factor of both factors, okay? And so that's going to send us, and I'm going to do this sideways because I'm running into my next example here. That's going to send us to do this. 2 factors out of that first factor to give us x plus 1. Nothing factors out of the next factor to give us 2x minus 5. And now step 5 says cancel out that greatest common factor you just brought out, and that's your answer. X plus 1. 2x minus 5. And that is supposedly the factorization for 2x squared minus 3x minus 5. Okay, let's check. Using the distributive property, not that godforsaken 4-letter F word, we are going to multiply and say x times 2x is 2x squared. And then we have 2x minus, or x minus 5 is times x times negative 5 is minus 5x. 1 times 2x is positive 2x. 1 times negative 5 is a negative 5. Combining like terms, we see it's 2x squared minus 3x minus 5. and we're okay. And so that's the AC method of factoring. That's our first example. Okay, now I'm going to move through the second example a little quicker. All right, example number 2. Okay, so I multiply first and last and remove the first. So I go x squared plus 23x plus 126. Here's the biggest problem with this particular method. Look at how huge that number is. You got to find 2 factors of that to add the 23. And so I do have a few things up my sleeve. So I would grab a calculator because you're going to have to be dividing 126 by some really weird numbers. First, you know that 126 is divisible by 3, and it's also divisible by 6, but 6 plus 21 is not that. And so is it divisible by 7? Let's try 7. So we have 126 divided by 7. And oh, look, it's 18. Okay, how about 126 divided by 8? We have that. Oh, nope, how about 9? 126 divided by 9, what does that give us? 14. Okay, so now I've got a couple of viable options. You'll notice I did not start with a 1 and 126 and then go down. Because 23 is so much less than 126, the factors are probably going to be very close together. And so I'm going to start more towards the square root of 126 to start my looking. And so we've got 7 and 18 were close. That makes 25. But then we had 9 and 14. That makes 23. So these are my 2. The second sign says that they must add together to become 23. It also says that the signs on the factors are the same. Be very careful. It does not say which sign they are. The middle term tells us that they must be positive. The larger term is positive. They're both the same, hence they're both positive. So I've got 9 and 14. Step 3, I come in, I put the 6 back in, and so 6x plus 9, 6x plus 14, 14. I now factor out the greatest common factor of both factors. So I bring out a 3 from here, and I get 2x plus 3. I can bring out a 2 from here, and I get 3x plus 7. And eliminate, as the final step, eliminate these 2, and those are my factors. One factor is 2x plus 3. One is 3x plus 7. A quick multiply through just to make sure that this works. 2x times 3x is 6x squared. 2x and 7 is 14x. 3 and 3x is 9x. 3 and 7 is 21. Combine like terms, I get 6x squared plus 23x plus 21. And that's what I started with. So I'm just going to kind of write this over here. My answer was 2x plus 3 and 3x plus 7. Notice again that I just completely dropped those greatest common factors off and canceled them right out. They just magically disappeared. Huh. Weird. Okay, number 3. Let's go ahead and start this just like we would anything else. We're going to take 10 and we're going to multiply it by 30 to get 300. And so we're going to have x squared plus 35x plus 300. Now we need factors of 300 that add to 35, and I think that's going to be 15 and 20. And so this is going to be x squared plus 15. Whoop, not x squared, goofball. I don't need an eraser quite that big either. There we go. X plus 15, x plus 20. 20 times 15 is 200 times plus 100, which is 300. Okay. 15 and 20, 15 plus 20 is 35. So there we go. There's our factoring. Now I put the 10 back in. So I say this is 10x plus 15, 10x plus 20, and factor out the greatest common factor. I bring out the 5. This becomes 2x plus 3. I factor out the 10, and it becomes x plus 2. And now if you look, I've got 2x and kill these. Bang, bang. I've got 2x plus 3 and x plus 2, and I don't even have to go any further. Because look, I got 2x and x for 2x squared. That is not 10x squared. Okay, and so if you use this method without factoring out that greatest common factor, it will destroy itself. It effectively does what you didn't do without you knowing what happened, and that's bad. Okay, so let's go ahead and I'll show you here that it does work, but you've got to kind of finagle it just a little bit. It still matches what I'm going to do on the second attempt here is it still matches what I show my students as a kind of a neat little algorithm to walk through. And the first step of the algorithm is factor out the greatest common factor from all the terms. So I've got 10, 35, and 30. A 5 is in common with each. So I'm going to go ahead and factor out a 5 for 2x squared plus 7x plus 6. Now what I'm going to do is I'm just going to I'm going to keep that 5. I'm just going to I'm going to put it over here in the cloud so I can pull it down later. But then I'm just going to concentrate on factoring out the trinomial that's left. And so 2x squared plus 7x plus 6. When I do that, then I go ahead and I bring that one over here and I multiply them together and I get x squared plus 7x plus 12. Well, that's a lot better because 12 is a lot smaller. And so now I'm going to go ahead and factor this. Just like before, this tells me the signs are the same and the factors of 12 have to add to make 7. This tells me that the larger factor is positive. Since they're both the same, they're both positive. I need two factors of 12 that add to 7. 3 times 4 is 12. 3 plus 4 is 7. So 3 and 4. Then I put the 2 in back, or I put the 2 back in as the lead coefficient of both factors. Whoop! That is not a 3 goofball, that is a 4. 4. And then if I can, I factor out the greatest common factor. Well, this is prime, relatively prime. 2 and 3 don't have any common factors. I can factor out a 2, and so I'm going to write down 2x plus 3 because nothing happens there. Then I can bring a 2 out and I get x plus 2. Okay. So now I get rid of this magical 2. So it just up and disappears. And now I'm left with 2x plus 3, x plus 2. However, remember that that was this factored. I still have this 5 out here in the cloud. I got to pull that 5 back down. So I'm going to let it rain back down here. And it's going to come out and sit outside. So now if I go through this, I go ahead and multiply this out. So it's 2x plus times x is 2x squared. 2x times 2 is plus 4x. 3 times x is 3x. 3 times 2 is 6. And then I have 2x squared plus 7x plus 6. I have all of that multiplied by 5, and so I have to distribute that 5. And that goes into 10x squared plus 35x plus 30, which is indeed what we started with. So remember, if you're using this method, and any method for that matter, always factor out the greatest common factor first. Always. Before you do anything else, that is the first thing you do. When you do that, then you can start to factor. If you love this method, I'm very, very happy. I have a different way of doing it, and somebody showed me, and oh, I think it just works wonders.